Okay, everyone, we'll get started now. Thank you so much for making it through 3 days of sessions and still coming to the one that's between you and the party. I really appreciate it. So hopefully you're here to see me pray to the demo gods and code most of the session. So we're going to be building a real-time data and AI pipeline, and we'll be setting things up a step at a time. So the first thing I'm going to be doing is I'm going to be kicking off the resource creation, because that can take a while. Don't worry too much about the small screen. That's for me, just to make sure I don't miss any important steps. Is the Azure portal screen an okay size for everyone? At the back? A bit bigger? Good? Awesome. Okay, so the first thing I'm going to do is I'm going to open up the Cloud Shell. So for those of you who haven't seen this before, this is basically a little terminal that allows us to directly program our Azure resources without us having to do any pesky authentication. And since authentication is like the hardest thing in the world, I think in software projects, second infrastructure, this really helps me out. Okay, so I'm creating a resource group called MS-Build2, and I'm going to be going through creating storage accounts, cognitive services accounts, a logic apps area, a Databricks cluster. I don't need to create a functions account, and I'm going to create some event hubs. So we'll see in a bit why I'm using all these different pieces of technology, but no one should have to sit through coding or the next on these. So whilst that bit's running, so I'm doing the as-CLI stuff at the moment. So as-CLI is the bit that's going on in the Cloud Shell. You can get that on your machines as well. So you can remotely set things up in Azure. Has anybody tried using ARM templates? It's painful. So when I got a command line, I was very happy. I am used to Bash, I'm used to PowerShell. That's how I like to do things. A couple of them I'll show you, I'll dive into it with things like Databricks, don't have a specific command line. So if you do have ARM templates sitting around, hard-won, blood, sweat, and tears kind of thing, you'll actually be able to use the as-CLI to deploy those as well. And then I'm going to use the Databricks CLI, but when I'm saying Databricks, I'll introduce that for you. So whilst it's happening, a little bit about me. Hi, I'm Steph. Once again, thank you very much for having the mental fortitude for third day final talk. So I run a couple of companies, Lock Data, which is a consultancy that helps people start doing data science, and Nightingale HQ, which is an AI adoption management company. So we're a startup helping businesses connect to data and AI partners and manage adoption. You can tweet me, and if you want to play with QR codes, that gets you on LinkedIn. And you can often see some of my code samples at my GitHub and the associated organizations that you can see on that profile. Okay, so what we're going to be doing today, and what I've already kicked off, is the resources bit. That's just boring single as-CLI commands. Then we're going to set up the signal. So our signal today is going to be MS Build tweets, and you're going to be able to contribute to these. The aim of this pipeline is to real-time ingest the tweets, understand what language they're in, how people are feeling about build, grab the images, and work out what is in the images. So whether it's a screenshot or a selfie or a picture of the conference floor or a picture of your shoes, I want to know. So real time, we're going to be getting that information off of Twitter, processing it. We're going to use cognitive services as a quick way of adding AI into this pipeline. But the mechanism I show you would allow you to drop in work from data scientists. And then we're going to push it to Power BI, real time. Okay? So here is how we can kick off a ARM deployment process, for those of you who want to know how to do it in the CLI. So we're doing a group deployment, and we can create it, and we put it with a unique resource URL, essentially, or a local file. And that's it, along with providing the parameters to it. So that can make life a lot easier. And now that we've got everything set up, I'm going to do a little bit of Databricks setup. So this is coding from scratch, kind of real time, but nobody wants to see me typo on stage, so it is a lot of copy and paste. So to work in the Azure CLI, it's actually, the Cloud Shell is effectively running Python, or can run Python. So what I'm doing here is making a Databricks environment called Databricks CLI, which I can then go into and provide everything I need to be able to directly interface with my Databricks workspace. So after I've installed the CLI, I now need to connect to my Databricks cluster. So I can do Databricks configure. This zoomed in doesn't leave me a lot of space. Okay. So the Databricks cluster is an analytics environment for data engineers and data scientists to work in. And I should ask, who's a data engineer? Okay. Data scientist? Infrastructure. Here, because it was easier than going back to the main building. Okay. So we're going to launch the workspace. And this gives me a user, a nice environment for me to work interactively. I need to go into this area to get a user access token. You can do it in the command line, but this is a good introduction to showing you how to do things in the user interface. So whilst that's connecting securely with my authentication, I first of all need this URL. And then I need to get that user access token. So in here, I'm able to start doing building data pipelines directly from Databricks. But for starters, I want to be able to go and grab a token. So with this now, I can securely talk to my Databricks cluster, Databricks workspace. The first thing I'm going to do is provision a cluster. So this cluster is going to start with two virtual machines plus a controller, and this is where I'm going to be able to do distributed analytics and processing. I need some extra bits and pieces, so I'm going to use this cluster ID. The first thing I'm going to do is install the Microsoft Machine Learning package for Spark. That gives us our capabilities to talk to cognitive services and do the real-time streaming to Power BI. And then the other thing which we need is the ability to talk to event hubs. Because event hubs will be our way of keeping track of all of our social media content. So that's going away and making the cluster. So let's look at why I'm doing these things. So when we have a real-time pipeline, or indeed any pipeline, data-wise, we usually have some sort of signal, something we're capturing. This could be once a day, we need to go and capture all the data from the day before. With real time, we're basically just trying to capture the data as close to being as to when it's generated as possible. So our signal capabilities, in this case, or some of the text that we can use are event hubs. Event hubs is basically a big queue where events like a tweet can go into, and then multiple things can process it real time. So they can be listening out for new things in the queue and process it. If all of a sudden the Twitter sphere explodes with MS build activities, and my compute resource is insufficient right now to process it, that queue just gets longer and waits around for me to be able to process it. So a queue allows us to react to scale without losing any activities. Then we need to be able to listen out for these signals. So Azure Functions, anybody done any serverless compute? Yeah? Love me a function. I have to write so little C#. It makes me happy. So an Azure function is a little bit of code that will listen out to some activity, do something, and then output something somewhere. Microsoft takes care of all the parallelization, all the retries, so you only have to write business logic. Then we have logic apps. Logic apps is how I'm going to actually do a lot of the work today. Logic apps is basically, if you've used if this, then that, or Zapier, this is that on steroids for your operational environment. So we're going to be able to listen out to tweets, chuck them into event hubs, get images off the internet, write them out to blobs, and be able to do that real time and parallelizable. Stream analytics allows you to be directly counting activities in event hubs. And you can also do listening out with Databricks. So you can start seeing we had 2 for signal, 4 things for listeners, and we're only part ways through this process. So there are lots of different pieces of tech that you can put together. And as I go through, I'll explain the reasoning why I picked some of the specific ones, And for most of the time, it's because it's easiest for my scenario. In terms of insights, we can be processing it and ideally supplementing our data with insights. So we can use cognitive services, which is Microsoft's off-the-shelf APIs to help us. We can use bespoke models produced by data scientists in Azure Machine Learning Studio, HD Insight, and Databricks. Finally, we want to store that data somewhere. So you have traditional databases as a service in Microsoft, in Azure. So you could write to a traditional relational database, whether that's SQL Server, MariaDB, Postgres. That is often not quite enough scale for the real-time processing. And they can often, it can sometimes be difficult having effectively a chatty application talking to a database. We can use Cosmos DB to be able to hold data in the JSON format that things tend to come in as events. And that's very scalable. We can put things into table storage. So has anybody used Have I Been Pwned? OK. HaveIBeenPwned.com, you all need to use it because it tells you when your data has inevitably been leaked to the world. OK? You'll go on there, you'll probably find your, the GitHub leak, the Dropbox leak, and the LinkedIn leak. At minimum, you've been pwned probably 3 times. So go on to HaveIBeenPwned.com. Troy Hunt runs a lot of that and a whole password checking service on table storage, and it costs him less than $50 a month for storage, including 500 million passwords. So it's a very cost-effective storage mechanism. SQL Data Warehouse, if you, and kind of a data lake environment you can be using to store data. Typically, that is better for large batch data rather than real-time streaming data. And we can also store things in Databricks. And Databricks can also have that data storage be blobs. And so you can then consume those blobs or data lake storage tier in other solutions. And then visualizing data. So Databricks does things again. So you can see all the way along that Databricks is actually a valid solution for many of these things. So we can build things. We can be putting this data into Power BI. And there is also what used to be called Kusto. And it's Azure Data something. You can call it Azure Microsoft 365 Power thing, and I wouldn't be able to tell you if it was a real product or not. So that's another solution that's very high scale and very responsive, and also in the cloud. So lots and lots of different pieces, and I'm going to show you basically my path through these for this real-time processing. But which one is particularly right for you will depend on your scenario. And I do have business cards at the back. I offer half-hour mentoring and office hours for free, so you can go on my website, book in, and we can chat about what's right for you. OK. So we're going to now move on to processing the signal. So I'm going to build the logic app that's going to grab the Twitter data, process it, and dump the images into blob storage. So there is no Azure CLI for logic apps right now. So I used a deployment template, and the basic deployment template has a simple capability in here which says every hour go do this thing, right? But we want something more responsive and listening out to tweets. So when a new tweet is posted, I need to sign in. And hopefully it won't take long for me to receive the 2FA. So it has a wide range of triggers, and you can create your own. But for now, we're going to do MS build. I'm going to poll this Twitter feed for new tweets every second. Then, because people do a lot of retweeting, and the retweets aren't very interesting in terms of original content, so we're going to filter those out. So when there was an original tweet, we won't be interested. But for the things that we're interested in, there should not be an original tweet associated with it. Then, if that condition is true, so it's an original tweet, we're going to add an action. The first thing we're going to do is we're going to send an event to Event Hubs. You can see it's guiding us through this process quite nicely. And we need to tell it what should go into the Event Hub, so that's the content of the event. And that content has to be encoded in base 64 for this. And we take the trigger body. So the trigger body is basically what the entire contents of the tweet, and we're turning it into a single message in here. That's a limitation of the logic apps that we have to work around. So once we sent the tweet to our queue, I then want to start getting all the images so we can analyze what's being included. So I need a for each. And we're going to do for each of the media URLs. We can add an action to do for every image. So we're going to do a HTTP call. And there's different types that you can do. So you can push data to external APIs and things like that, or authenticate. And we need to process the current URL that we're on. Once we have that image, we then want to write that to blob storage. So we're going to create a blob. We're going to put them in a folder called images. The blob name we need, so I'm going to make an expression. And I'm going to grab basically the directory and the file name of the image. And this is a little bit flaky, so you can see it's no longer coming up with current item. The plus side is we get a code view, and the logic app is entirely a nice JSON representation. So we can see in here that we've got this create blob, and we can put in here our for each, and we can nicely just copy and paste from our earlier action. So I can now flip back to the design view, and that's made the for each. The blob content is going to be from our HTTP call, and is going to be the body, because that's where the image is being returned. And that is our real-time listener. Everything okay? I don't know if it's giving me an error message that I can't see. I'm going to let this think about whether it wants to hit save. The next thing that I need to do, so cognitive services that process images, which we'll be using to kind of work out what's what going on in the images, have a maximum image size of 4 megabytes. Unfortunately, we all have phones that are like shooting in 4K and stuff at the moment, which makes it rather difficult to send them just by default into cognitive services. So what we need is to be able to resize those images. Thankfully, somebody made a very nice repository, Azure function for that resizes images. Now, it's meant to do thumbnails and shrink things, but we can actually use it to resize things to any dimensions that we want. So I can deploy this to Azure. So on GitHub, there are a bunch of these Azure functions and other projects that can deploy to Azure, and you can just press a button. Somebody will have done the hard work on basically an ARM template, and we can go through and make that happen. My Wi-Fi is basically non-existent, which might be why everything is going slowly on this. Worst comes to worst, I do have videos that I recorded at about 4 o'clock this morning because I came over from the UK and I still am rather jet lagged. So we'll give this a little bit more time to think. I've also, of course, as well as a video showing how to do things, got a here's one I made earlier, proper Blue Peter style. And I can spin up a hotspot. Since I have 4G, hopefully this will be quicker. whilst this is sorting itself out, we can recap. So the signal that the logic app is going to consume is MS build tweets. I want us to get a bit further on so we can start seeing the data properly streaming in and the images resizing. But once that's ready, I want you to be tweeting like mad so we can really get the volumes up and kind of stress test my solution. So those are anything with the hashtag MSBuild we'll need. Our listener is a logic app. So that logic app is listening out for tweets every second, grabbing every new tweet, and then if it's got images attached to it, it's saving down those images into a blob container so that we can then process them real time as well as processing the text. Hopefully it's not just my Wi-Fi card is deciding to be the single point of failure. One of the good things about a logic app being code is I can hopefully just paste in the contents. So I'm going to work here on the black side, not the blue side. I'm deploying to Azure. And I need my I guess I'm fully breaking Azure. Oh, that won't have me logged in. Does anybody remember the randomly generated number that I have for that I so cleverly put on to avoid collisions with anybody else's demos? Oh, it's not in there. Okay, there's my. Here's one I did earlier. We've got that saved, that's going. Then we're going to do our deploy to Azure. So just putting in the pre-existing storage. That'll just save us some sprawl in terms of our resources. And then once we have this function in production, in this version, I need to go into the environment variables for the function and basically set what dimensions I need, because by default, they're 100 by 100. And you have to make sure you give it sensible names. So once that's built, we fill in that info, and we have a working function that listens out for blobs and resizes them as they come in. Yes, something went very wrong, Azure. Let's see if it's fixed itself. Okay. So once we have the thumbnail, it's calling it thumbnails by default. We will then want to basically set up an event hub that is getting those URLs of the blobs that we've created so that we can send those URLs to cognitive services, which will enable us to process them more easily instead of slinging around the whole images. So event grid is basically a snazzy way of managing subscriptions to events inside your Azure environment and externally. So here I'm creating an event subscription. This is even lighter code than having to create an event, a logic app or a function. And I love things being the simpler the better. And talking to somebody yesterday from the Microsoft teams, when you have a function that listens out for blobs, it does a lot of active polling, whereas this is a push notification capability. So it's actually saving the planet because we're doing fewer computations. We won't see any cost difference because the same number of functions will execute, but it's a little bit kinder on the planet by using event grids. So we're making sure that we're only working with the stuff that's hitting the thumbnail directory, because otherwise, if we're getting the images directory, that's when we can get the big things as well. And we also don't want to double process, because then that means we do double the cost by using cognitive services. So we're going to create the event grid and sync to event hubs. And now that is active and listening. So that will then give us all the capabilities that we need. Azure is really determined that I've broken it. Which means I won't even be able to start up my cluster. Okay, it is a good thing I have a video. So now that we have basically the full data ingestion and processing of the images in preparation for our AI components, we can now start working in Databricks to be able to do the real-time processing and adding the AI results to the stream. So I created some different notebooks that do the different pieces. I can't zoom it over an image, unfortunately. But the first step we do inside Databricks is we configure a connection to event hubs. With that connection to the event hub, we can start a real-time stream in Spark. Spark has had real-time stream inside Databricks. It's had the capability for about 3-4 years now. So Databricks will just natively handle this, and you can have a visual inside the notebook environment, which is basically a code environment that doesn't have code completion, and be able to see activity coming in. So the first thing we do is we connect to the event hub, we get the contents out, and I basically unbase64 it to get the JSON back from the tweets. Once we've got that being loaded up and made available in Databricks, we can then start doing the AI processing. So we need a cognitive services key for this, but as I said earlier, this could be any machine learning model or algorithm that somebody has made. I'm much slower when I'm actually doing things. So we're going to get the key for cognitive services and put it in. Again, this is using the Microsoft Machine Learning Spark library, which is open source. So it isn't just restricted to Databricks. You can use this on any generic Spark instance. And you can see we're starting to get tweets. And once we've got the cognitive services, we can start specifying transformations. So a transformation is grab, in this case, make a prediction. So can we go to the language cognitive services and get the sentiment and the language detection? So we specify those as transformers, which is great. We get to think about transformers and how we're taking over the world with artificial machines, and generally have some fun with that. So each one gets specified, and that will add a column to our data set, which has basically the payload back from the Cognitive Services API. And it'll do it for every tweet that's coming through and streaming through our process. We can then also add some extra transformers that pull some of that information out. And we use a concept called a pipeline model. So with Spark, because data scientists might do, and data engineers as well, will do some feature engineering to tidy up the data, and then maybe score the data with multiple models to be able to see which one performs best. We have this concept of a pre-specified pipeline. And that pipeline is going to enable us to do all the transformations in sequence. Where did it go? I must remember I cannot scroll. Okay. This is a little bit small, and hopefully if I can get my Azure working, because I'm not showing the pieces here. But a pipeline model is a regular occurrence inside the Databricks and the Spark processing. So that's an area where, which is something that your data scientists might be used to building. And Another new thing that I've integrated into this is the very confusingly named Delta Lake. So Delta Lake is basically the Spark data lake. Only it allows us to do deltas, which are changes. So we're able to stream data into this Delta Lake, and it will partition the data and grow the data set, enables various things like row versioning, and we can then turn it into big blocky Parquet files for bulk processing. So that's another thing that we're using to improve the reliability of this pipeline behind the scenes. It's just thoroughly broken. Okay. So with the tweets, we get the language detection, the sentiment analysis, and we could do other things. So you could put spacey models in there for NLP understanding, knowledge extraction, and things. When we work with the images, we basically have the same process, because now we have a URL, an event hub, streaming URLs to be processed. So we set up the Delta Lake for image streaming. We set up our transformations, our AI transformations, and we stream our pipeline through them, and our pipeline of data start accruing extra columns of insight, like category of the things inside the image. Once we have those, once we've supplemented the data with our predictive models and our intelligence and stuff, we can then start real-time analyzing it. We can do real-time analysis in Databricks. So Databricks has the ability to basically have dashboards inside it, which will update every time there's some new data in the streaming model, or we can push them to Power BI. So when we process it in Power BI, we use the real-time dataset capability. I hope my Power BI at least hasn't broken. Okay. So obviously, my streams are not pushing to these tiles right now. You see the little lightning bolts next to them? That's an indicator that this is meant to be where a real-time feed goes. So typically in Power BI, we have effectively a static data set that gets imported and cached on a regular basis, or we have direct query where it will go and run the query against the data source, but it only does that effectively on the caching side on kind of a quarter-hour or half-hour basis, or on the direct query side when the data gets loaded and you start interacting with the charts. With these real-time tiles, the API sending data to it forces these to change when you're actively running things. So as traffic hits your website, as customers do things, or as you monitor your brand after a PR story, you can be seeing it real time. And you can set these capabilities up quite easily. So you can create a streaming data set. And you've got PubNub. You might have seen PubNub in the expo hall. You could talk to them. That's often used as basically a system for managing IoT streaming data sets. You can use Azure Stream Analytics, or you can use any old API. So one of the pros and cons of the streaming data set is Power BI expects you to know what you're going to send to it. Good thing, because you should know what you're sending out into the world. Bad thing, it means if a developer changes something and doesn't tell somebody, then your streaming data set can break. So you just go through and you specify, in our case, for the sentiment analysis results, we've got the tweet, the sentiment score, and the detected language, and the enqueued time to tell us when we registered it, so we can do time-based charts. In the case of our images, it would be the enqueued time, the image URL, so we could potentially fetch that later down the line, and the category of the image. So I would very much like to get this working. And maybe it's just my specific session that broke. It seems unlikely that Azure is broken for everyone. Okay. So I'm going to open up the here's one I made earlier. My logic app and function are already running in this, but when we have a cluster, we're running a number of fairly expensive virtual machines. So we don't want these generally running, so I turned them off. I probably should have turned them on earlier. And one of the great things about Databricks is it will turn your machines off if you're not using them. Now, if you have streaming jobs going, they'll never turn off because those streaming jobs are active. But this is useful for when you're doing analytics. Okay. So first thing is I need to, so now we can see the code a bit better. We've got our connection string, our event hubs configuration, and then a read stream, which is basically reading from event hubs. And then to make this accessible in other sources and for other people to work with, we're writing it to a Delta lake. So I'm going to queue these for when the cluster is started. And ditto with the image schema generation. We can see some of the code now. So this is the image supplementing. I'm reading that delta space that I created. Inevitably, you have to do some changes to the message because nothing ever writes when you're not in control of the schema, things don't always write perfectly. So there's some data transformation that you have to do, and we're extracting pieces out of the JSON that gets produced. I've got my image transformation, so I'm using analyze image. I'm putting in the key, what endpoint I'm meant to use, and specifying my output column. I'm then also doing a SQL transformer to extract some of that JSON programmatically. Writing a pipeline model, which is what things do I want to apply to my stream of data. And then I transform my stream with those planned actions. And again, every time I do a cleaning process, I'm opting to write these into a file storage system. This means that if I'm building a kind of this in a team setting, different teammates can pick up the stream at different points necessary for whatever process they want to kick off. So instead of us all listening to the tweets and kind of repeating and costing us lots, we're instead getting one set of tweets in, and multiple people can then process them cheaply. So I'm going to kick this off. And I'm going to kick off the tweet schema. So working with Power BI, I'm simplifying my data structure. So I'm basically selecting just the few columns that are interesting. And then these 2 lines of code are all you need to send that real-time feed to Power BI. So we've got Power BI writer stream start, which is basically an instruction of how to do things. And then the process all available is, as you get more data into this stream, keep sending it. So this is all kicking off, waiting for tweets. If you can speed it up, give it some MS builds. Let's make sure nothing's errored. No, we've still got lots of streams initializing. So Spark does have an overhead to getting all of these things going, because they basically go into a big scheduler, and the scheduler works out how to run them so that nothing breaks. just in time. So here is the feed of the images has come through, and we're seeing abstract non-photos, abstract pictures, pictures of people, and pictures of others. Basically things it couldn't classify coming through. And as it processes images, so as it receives a tweet, then checks out the images, saves them to blob storage, resizes them, processes them through our Databricks pipeline, and categorizes them with cognitive services. It appears in here. And you can also see the sentiment of tweets as they're coming through, and what language they're in. So by and large, most tweets are in English. So that is the end-to-end pipeline. It sucks that Azure broke. Thank you, everybody, once again for being here. Various people helped make this thing a reality.
Do you want to stay and take questions?
Yeah.
That's okay. I just have to take the video adapter and then be done in 10 or 15
Yep.
minutes. Okay, great.
Okay.
Actually, yeah, the mic and the video adapter.
Yeah. So if you want to give some of these a go, there's a solution gallery. And you'll be able to get these. If you go to github.com/lockdata, the first repository in the list will be my real-time AI pipeline. That has the instructions, step by step, and a load of follow-up resources.
Don't need that, I'm sorry. I gotta go, but.
Oh no, if you got to, yeah.
Yeah, we have a meeting.
Yeah.
Sorry. You can stay.
Yep.
You know, that's fine.
I got to take the mic off.
Yes.
Yes.
Come on up and visit.
Yes. Thank you all.